Hello everyone. Today we are going to study the third part, the frequency domain analysis for continuous system of the signal and linear system. In this module, we will study the method of frequency domain analysis of continuous system. Before studying this module, in this lecture, I will first introduce why we should study frequency domain analysis. Then introduce the teaching method and teaching contents and requirements of this module. Finally, I will introduce the key points and difficulties of this course. In the second module, we have discussed the method of time domain analysis for continuous system, namely solving the differential equation to analyze zero input response, zero state response, and complete response of a system. We mainly discussed three working modes of second-order system, focusing on the input and output of time domain of continuous system and their changing rules over time. In this module, we will study transform domain analysis. First, we will discuss the Fourier transform. Fourier transform is developed on the basis of expansion of orthogonal function of Fourier series. This problem is also known as Fourier analysis or frequency domain analysis. Frequency domain analysis transforms the time variables into the frequency variable and reveals the intrinsic frequency characteristics of signal and a close relationship between the time characteristic and frequency characteristic of signal. Let's move on to the teaching method. First, we will discuss the orthogonal functions of Fourier series, and we will introduce Fourier transform and learn the concept of signal spectrum. In the discussion of typical signal spectrum and the properties of Fourier transform, we will introduce the engineering application of Fourier analysis method and analyze the engineering cases. In the discussion of method of frequency domain analysis for continuous system, we will introduce the concept of frequency response function, bandwidth, the concept of filter, and the characteristic of ideal low-pass filter in distortionless transmission system. Finally, in the discussion of Fourier transform of sample signal, we will introduce sampling theorem and analyze their engineering application. The main contents and requirements are as follows. First, you are required to learn the purpose of decomposing signal into orthogonal functions, master the method of decomposition. Second, you should study the formula for Fourier series expansion of periodic signal and grasp the spectrum characteristic of periodic signal. Next, learn the concept of signal spectrum in Fourier transform, the concept of signal sampling, the frequency domain response function of LTI system, the properties of Fourier transform and its engineering applications, as well as the spectrum characteristic of AM signal. Next, you shall master the physical meaning of sampling theorem and the convolution theorem and apply them correctly. You should master the method of frequency domain analysis. Finally, you should understand the energy and the power spectrum, Fourier transform of periodic signal, and the concept of distortionless transmission, and master the characteristics of ideal low-pass filter. The key points and difficulties of this part are first, the frequency domain characteristic and analysis method of signal. How to correctly master the relationship between time domain and frequency domain characteristics of periodic signal and aperiodic signal and its application in engineering. Second, the concept of signal sampling, the spectrum characteristic of sample signal, how to correctly master the content of convolution theorem and sampling theorem and apply them in engineering, and improve the ability to solve engineering problems, master the mathematical model of time domain and frequency domain of AM wave, and analyze its spectrum characteristics. This module is divided into 15 lectures. First, Introduction to Frequency Domain Analysis module of Continuous System. That is what we learned today. Second, Orthogonal function decomposition of signal. Third, Spectrum analysis of periodic signal. Spectrum characteristic of typical periodic signal. Spectrum analysis of aperiodic signal. Spectrum characteristic of typical aperiodic signal. Spectrum characteristic of singular function signal. Properties of Fourier transform and its engineering application. Energy spectrum and a power spectrum. Fourier transform of periodic signal. Frequency domain analysis of LTI system. Distortionless transmission. Ideal low-pass filter. Spectrum characteristic of sample signal. And the last one, sampling theorem and its application. I will teach you all of that. I hope it can be useful for your study. So much for today. Thanks for your attention. Goodbye.